Welcome to the deep dive. We got a great question from you about split air conditioners.
Yeah, specifically why it's so darn hard to find units with power ratings below 1 kilowatt here in Germany.
Exactly. Especially with modern builds, super insulated, maybe tiny rooms, like 8 square meters. You need something small.
Right, but finding those sub 1 kilowatt units feels like looking for a unicorn sometimes.
So today we're digging into that. We've looked at the tech specs, the market forces, all that stuff.
We're trying to unpack the technical reasons, the economics behind it, and also this difference between the advertised power and, what it actually does.
And that annoying cycling issue, too, where it clicks on and off if it's too big for the space.
Definitely. So our mission today is to give you a clearer picture of why these tiny units are so scarce.
Hopefully helping you avoid pitfalls if you're trying to cool or heat a really small space. Should be interesting.
Let's jump in. First up, those power ratings.
Right. You see 2.5 kilowatt unit advertised. What does that actually mean in practice? Is that the minimum power?
No, not usually. That's typically the nominal power or Nennleistung. Think of it as the advertised power under specific test conditions. It's mostly for marketing.
Okay, so not the lowest it can go.
Exactly. What really counts for a small room is the actual output and, crucially, the minimum output it can sustain. That's where inverter tech comes in.
Ah, the inverter. That allows it to adjust its speed, right? Like dimming a light bulb instead of just flicking it on or off?
Precisely. Modern units modulate their power. They ramp up and down to meet the actual heating or cooling demand.
So the key term we need to look for is?
It's the minimum modulated power, sometimes called Regelbereich on German datasheets. That tells you the lowest stable level it can operate at.
Okay, so give us some examples. Can a bigger unit actually dip below 1 kilowatt?
Oh, absolutely. Take a Remco ML265 DC that's rated 2.6 kilowatt nominal, but its minimum is listed as 1.0 kilowatt.
Okay.
Or a Panasonic Etheria Z25 XKE, 2.5 kilowatt nominal, can go down to 0.85 kilowatt.
Oh, okay, so quite a bit lower.
Yep. Mitsubishi Electric MSC EF255VG, 2.5 kilowatt nominal down to 0.9 kilowatts. Even some slightly larger ones, like a Kilterbringer 12,000 BTU, which is 3.4 kilowatt nominal, can sometimes modulate down to around 1.0 watt.
So many standard 2.0 or 2.5 units can actually operate in that sub 1 kilowatt range we're looking for.
That's the main point. They often can.
Which begs the question then, if they can run that low, why aren't there more units specifically designed and advertised as, say, 0.8 kilowatt nominal? What's the technical barrier?
Right, that's where it gets tricky. Making the whole system compressor, heat exchangers optimally sized for such a low nominal rating, presents challenges.
Like the compressor.
Yeah, the compressor motor needs a minimum speed to run smoothly, and really importantly, to ensure the lubricating oil circulates correctly back to it.
Ah, oil return.
If it runs too slow, the oil might get trapped elsewhere.
Yeah.
So often the practical minimum output is maybe 30%, sometimes 40% of the nominal power, just for reliability.
And outside temperature affects this too.
Especially for heating. When it's milder outside, the system might struggle to run at a very low heating output stably. The minimum might actually creep up a bit.
Interesting. What about the other parts, the heat exchangers?
Well, there's a trade-off. You want them small for a low nominal power rating, right? But making them too small can hurt efficiency, the SEER and Syscott ratings.
Like trying to cool a room with a tiny, tiny fan, it has to work harder.
Sort of, yeah. And getting the refrigerant to distribute evenly through a very small heat exchanger at very low flow rates, it's also difficult. That can lead to inefficiency or even icing up.
And the whole refrigerant system itself.
It needs enough flow for that oil return we mentioned, and for the electronic expansion valve, the EEV, to work properly.
Yeah.
These small systems are also very sensitive to having the exact right amount of refrigerant. Too much or too little really impacts performance at low loads.
Okay, that makes sense. And this all connects back to that cycling issue in small rooms.
Exactly. If the room only needs, say, 0.5 kilowatts of cooling, but the unit's minimum output is 0.9 kilowatts, it's going to overshoot the target temperature quickly and then shut off.
On, off, on.
Off, yep. Which feels uncomfortable, wastes energy during startup each time, and puts more wear on the components. It's common in well-insulated small rooms or during spring and autumn.
So definite technical hurdles, but what about the market? Is there just not enough demand?
That's probably a big part of it. Units with a nominal rating below 1 kilowatt might be seen as a niche market. Is it worth setting up production lines just for them?
Especially if, as we said, the slightly larger units can often modulate down anyway.
Right. Plus, there's a tendency maybe historically to oversize units a bit. Better safe than sorry. This might mask the true underlying demand for genuinely tiny capacities.
So manufacturers just stick to the popular sizes?
Pretty much. They focus R&D and production on the bread and butter sizes, maybe 1.5 kilowatt up to 3.5 kilowatt nominal. That's where the volume is.
Does it cost much less to make a tiny unit?
Probably not proportionally less. Some core components cost what they cost, and making them significantly smaller might even require specialized, more expensive processes.
And installation costs are pretty fixed anyway, right?
Exactly. So saving maybe a little bit on a much lower powered unit might not seem worth it to the end customer once installation is factored in. Manufacturers also compete heavily on efficiency ratings, smart features, design, often within those established power bands.
And global markets matter too, I suppose. Germany's high insulation standards might not drive global product lines.
That's a factor. What sells well globally might take precedence over specific regional needs.
Okay, so reality check time. While finding a unit labeled 0.8 kilowatt is tough.
Many common units can operate there, you just need to check the specs carefully.
Are there any smaller nominal units readily available, like 1.5 kilowatt?
Yes, absolutely. Brands like Mitsubishi Heavy Industries, Mitsubishi Electric, Daikin, they definitely offer 1.5 kilowatt, sometimes 1.8 kilowatt or 2.0 kilowatt nominal units. And these very likely do modulate below 1 kilowatt.
The key takeaway then is,
don't get too hung up on finding a sub 1 kW nominal rating. Instead, look at the readily available 1.5 kilowatt or 2.0 kilowatt units from reputable brands, and always check the technical data sheet for the minimum modulated power, or Regelbereich. That's the crucial number.
So the unicorn isn't quite a unicorn, it just wears a slightly different label.
You could put it that way, yeah. It's about understanding that specification sheet.
Right. So wrapping up this deep dive, the core message seems to be, don't despair if you can't find an AC advertised as 0.8 kilowatt.
Exactly. Many of the smallest standard split systems can actually deliver that low output thanks to their inverter technology. You just need to know what to look for in the tech specs. Market forces and those technical limits we discussed just mean manufacturers currently favor slightly larger nominal sizes.
That's really helpful. And looking forward, what do you think?
Well, it's an interesting thought, isn't it? As our homes get even better insulated, the heating and cooling loads, especially in smaller rooms, will keep dropping.
So will manufacturers eventually have to focus more on optimizing for these ultra-low loads?
Maybe. Perhaps we'll see new refrigerant technologies or more advanced compressor controls that overcome some of the current limitations, like oil return at very low speeds. It's definitely something to watch.
A fascinating space to keep an eye on. We really hope this dive cleared up the mystery of the missing sub-1 kW air conditioners for you.
If you have more questions on sizing, or maybe you're dealing with cycling issues yourself, head over to our show notes or find us on social media.
We'd love to hear your experiences. Thanks for diving deep with us today.